This is Dr. Carroll, and in this video I'll be stepping through some string exercises to gain some experience about strings. Here we go. So the first question, what does the following display? Let me show you here in highlighted with color syntax. So we have a string object and we've just assigned it the letters JAVAC, and then we have source code string exercise assigned to string exercise.java, and then compiler is this first string reference. And then we're calling substring on it and passing it 0 and 4. And then for source code we're looking at substring 2 and 6, and then we're just passing substring 1 number here. So this would be a great opportunity to pause the video and think about what it is. So to uncover what this is, let's provide some numbers here to wrap our heads around this a little better. 4, 5, 6, 7, 8, 9, 0, 1, 2, 3. Okay, and here we're going to need just a few more numbers so the top row is the tens place and the bottom row is the ones place. So this is 10, 11, so that we can read this. Oh, sorry, wrong language. No, that didn't look quite right. Okay, there we go. Now they are Java comments. Okay, so substring is going to start at this index, so index 0, and go up to, but not including this last index. So this one is going to display Java. Let's see, substring 2, 6. So start at 2, but go up to 6, but don't include it. So it would be ring. And then let's see, 17. What do you think is going to happen here? We're going to start at Java, and we're just going to go to the end is what it's going to do, because that's the default, and so common thing to start it and go to the end. So let's see this. Let's compile this. All right, it compiled. And sure enough, Java, ring, Java. All right, one down. Good job. Now what does the following display? We have a string literal concatenated with 5. Okay, I have 5 fingers on one hand and 5 fingers on the other hand, so I have a total of 5 plus 5 fingers. Let's see it. Just so you know, I've got nothing up my sleeves. So, yep, that's all that this is. I put it in a public static void main. Let's compile it. And I have 5 fingers on one hand, 5 fingers on the other, so I have a total of 55 fingers. Wow, okay. Let's see this one. So what's going on here? Let's step through this. So we have a string literal, and then what is this? It might look like an addition operator, but it is a string concatenation operator. And so this becomes like that. And so we are concatenating a string and an int, and in Java, unlike Python, it says, yeah, we're good. I know how to concatenate a string and an int, and it looks like this. So then we have a string concatenated with a string. Well, it knows how to do that. It concatenates a string with a string. Again, it knows how to concatenate an int and a string and a string and a string. And now here's where it gets interesting. So now it says, okay, I'm concatenating a string and an int. So it says, okay, I know how to do that. It goes like this. And then it says, I'm concatenating a string and an int. Oh, I know how to do that. It looks like this. A string and a string, and then that's where we have the output. So just to be clear, so nobody's wondering if I have 55 fingers, what we need to do is change the order of operations here, so we do the math and then it gets concatenated. Okay, let's see it now. I have 10 fingers. Woohoo! Great. Okay, so that's fun with string concatenation. Okay, let's look at what index of is going to do here. So I've got this already typed up. So we have compiler is Java C, source code, strings, exercises. In command line, we've concatenated not an empty string because it has a space in it, but the first string, a space, and a second string. We're going to display that, and then we're going to display Java is found at index, and then using this command line string here, we're going to look for the index of Java. Let me just back it up just a little bit. And so as the method name suggests, we're going to look at the index for it. And since that is going to be right up front, it should return 0 here and display 0. Oh, same thing, except now we provided a second argument which says where do we start in that string. And so Java, so this command line here is going to be Java C space string exercises. So this will step over the first instance of Java, and then we'll look for any other. I think it'd also be interesting to look for, let's see, what should we do? Java, and let's do that as well to see what that returns. And then last index, not quite index of, but last index, we're looking at Java, is going to look from the end of the string backwards. And since it actually ends in Java, it's going to report where does this end. So let's see this. Java C. Woohoo! It compiles. Okay, so Java lowercase is found right at the beginning, and that's to illustrate this is going to start at 0. But notice there's no uppercase Java in command line. And so it returns a -1 to indicate, because in Java, -1 is not a valid index. Java, passing it, starting at index 5, 0, 1, 2, 3, 4, 5, starting here in the highlighted string, it says, hey, I found it at 23, which is from the beginning, but only consider this substring. And then the last index, 23, not surprisingly, is the same. All right, let's keep going. Okay, discuss with someone else. I guess that means you. The important difference between string object and a string buffer or string builder objects. Generically, these are called string buffer objects, with buffer being a second word and lowercase. But so let's look at the official documentation on string buffer. So and while there's a lot going on here, we can ascertain what we need just from the beginning. A thread safe, mutable sequence of characters. Okay, and they're nice here, and they didn't need to, but they expounded on what does this last phrase mean. A string buffer is like a string object, but can be modified. Okay, and I've got string already up here. It represents character strings, and then here it mentions strings are constants. They cannot be changed after they are created. And it gives a little hint here. String buffers, for example, string buffer or string writer, support mutable strings because string objects are mutable. Okay? So that's the big difference. String cannot be changed, whereas string buffer or string builder can be. And so then you'll say, well, which one should I use? Well, if you're going to modify the contents of the string a lot, then use a string buffer or a string builder object instead. Okay? I'll leave the optional exercise here to the interested viewer. All right, let's look at this last one. I've already put it in code here. A little too big. So declare a string object named name and assign it your name. Okay, well we can do that. And we can do it multiple ways. So string name equals, and we could do it very formally just like any other reference. And we could say Dr. C here. That's my name, my short name. That takes more characters, and so we could alternatively just do this as we just saw with the string documentation. But I mentioned this way to indicate that, hey, they are string objects, that they are references, and so all other references except primitive wrapper classes, we use new, the class name, and then potentially send the constructor an argument. But this is how we typically do it, because this is more characters. But either way would work. Okay, let's declare another string object named name lowercase. Let's use this second version here just to show it will compile. Okay, name lowercase, and never mind, it won't. Anyway, let me read the thing here. And assign it to lowercase version of the string using a string method. Well, we have already got it pulled up, so let's look here. What's our methods here in string? Char at, compare to, we'll talk about contains. We want a lowercase version. So what if we just search for to lowercase? Okay, there we go. And notice the casing, capital L, capital C. Okay, converts all the characters in this string to lowercase using the rules of the default locale. Now, to be clear here, to lowercase returns the string that is converted to lowercase. It does not modify this representation. Okay, so we need name to lowercase here. And now name is going to stay the same, but this is our lowercase version. And just to illustrate this point, let's do this. Let's display it here so that we can see that that truly is the case, that we have not modified name here. Okay, now what will the following display? Name, equality operator, well, this is just a string, but the actual, what it's doing is here, and I've wrapped it in parentheses so that we get the order of operations right. So name equals name lowercase. So this is going to test if name, which is a reference, and so references store the address of the object, has the same value or address as the name lowercase reference. And no, they are not the same reference. They're not pointing to the same location in memory, so this will be false. And we could do equals here and say, hey, equals looks at the characters to say if they are false. And then we could do compare to. And I think what would be helpful here is, what if we change this to, let's make a copy just to see the other way. Let's make a string name copy and assign it to name. Okay? So now we're taking this location and we're assigning it to name copy here. And for completeness, let's also display it. All right, let's see this. Java C. Woohoo! It compiles. Okay, name, Dr. C, lowercase. Sure enough, it did lowercase. And remember, name did not get changed. So this says they are not at the same address and they do not contain the same sequence of characters. And compared to, oh, we didn't talk about compared to what it does is it compares this, the name, to this one, and if name is not this, well, if they are the same, it will return 0. If name, and it lines them up from index 0, index 0, and if it finds a character in there, and the character in this, or name, is lower than the character that's in the argument, then it will return a negative number. Now in practice, it is the difference in ASCII values, but you can't guarantee that. So you should always test this with a range, inequality, meaning less than 0, instead of looking for the actual value. Alternatively, if name had a character value larger than the same one in the same position as name lowercase, then it would be a positive value. Okay, so we made a copy, and sure enough, they do reference the exact same object. They are the same, and what went on there? Oh, I was like, sorry. There was one more reference and I didn't get it. That's weird. I don't know why I didn't get it. Okay. Sure enough, 0. Okay. And now had we made a new string, let's do one more version here. Let's see. We'll call it different. Okay. Now let's. Okay, good. We got it in all places. Now I want you to pause and think, what's going to happen? Oh, sorry. This is new string. And so what we're going to do is we're going to make a new string, and we're going to say base it off this string and call it name different. So what's going to happen as we run through this? Are they referencing the same location? Do they have the same character value? And then this is a more complete look. Instead of true or false, we're looking at, are they the same or greater than or less than? It compiles, so we're looking just at this part. So sure enough, Dr. C has the same characters, but notice they are not pointing to the same location. When we called new string, it allocated a new place in memory and made a copy of that first one. But when we do equals, we say, hey, do they have the same characters? Yes, they have the same characters. And so anytime this is true, this is going to be 0. Well, I hope that was helpful. Let's see, and that completes this video.